We are back. So our goal in this video is to use what we know about the angle addition formulas for trig functions to get other sorts of results. So what we've done already is we've done explicit computations. We've used these identities to compute things like the sine and cosine of 5 pi over 12, which otherwise would have been impossible. Impossible is the wrong word. Otherwise we would not have, we did not know what those were before. Let's explore something different. Let's suppose I don't tell you what two angles are, but I do tell you what the trig functions at those two angles are. Let's suppose I give you two angles, A and B, which satisfy that. Let's even highlight. The cosine of A is 3/5. The cosine of B is 5/13. A is between 0 and pi over 2. And B is between 3 pi over 2 and 2 pi. Let's try to compute the cosine of A plus B and the sine of A plus B. And I know that I'm going a little bit out of order, but I want to explain why we care about sine of A and sine of B before we fill those in. So by the angle addition formula, the cosine of A plus B is equal to the cosine of A multiplied by the cosine of B minus the sine of A times the sine of B. And these formulas for angle addition and subtraction are formulas that you really should just have internalized and written down on note sheets in advance of the exams coming up. Similarly, the sine of A plus B is equal to the sine of A times the cosine of B plus cosine A sine B. And let's just go ahead and look at what we have. So cosine of A we know. Check. Cosine of B we know. Sine of A we need to know if we want to use this formula or that formula. Sine of B we need to know also. So let's go ahead and compute those. We have a strategy though. We already know how to compute sine and cosine. We already know how to compute sine of A if we know cosine of A. So go ahead and do this on your own, or if you prefer to follow along with what I do, do that. So I know that sine squared of A plus cosine squared of A is always equal to 1, but I know what the cosine of A is. The cosine of A is 3/5 squared plus s squared all where s equals sine of A. So here I have used, oops, that's not what I wanted, the fact in yellow. So let's go ahead and use this to solve for s. And you already know what I'm going to do, and you probably already know what the answer even is. So I get s squared equals, let's see, 3/5 squared is 9 over 25. So I'll need a common denominator of 25. So I'll write that 1 as 25 over 25 minus 9 over 25. And maybe just to help you out here, that 9 over 25 is that 3/5 squared. Writing that out, we get 16 over 25, so s is plus or minus the square root of 16 over 25. It's not a very good 6, is it? 16 over 25. And the angle A is between 0 and pi over 2. That means that A is in quadrant 1, so sine of A is bigger than 0. So sine is positive, the square root of 16 over 25. But looking at that square root, I only see perfect squares on the inside. That is 4 over 5. So that means that the sine of A is equal to 4 over 5. Now I know what the sine of A is. So I know that. I still need to know what the sine of B is. Well, let's do that. In fact, if you want to go ahead and pause and do that on your own and then watch my computation at double speed or something, do it. So let's compute it. You want to know what the sine of B is? Well, I'll use the same fact. Sine squared of B plus cosine squared of B is equal to 1. So that will tell me that s squared plus cosine of B is 5/13. for emphasis. Oops, that's the wrong color. 5/13 squared, where that highlighting is supposed to tell you that that fact is coming from the highlighted fact on the top of the screen, equals 1. And again, let's just follow through. So that means s squared is equal to 1 is 13 squared over 13 squared. 13 squared, if I recall correctly, well, let's just do it to the side. 13 times 13, 3 times 3 is 9, 3 times 1 is 3, 0, 130, that's 169. S squared, so I'll write this so that 5 over 13 is the same thing as 25 over 169. So 169 is the common denominator. So I'll write that one as 169 over 169 minus 25 over 169. Doing the subtraction, I have a common denominator, so subtraction is easy. The denominator will be 169, which, remember, is 13 squared. And in the top, 9 minus 5 is 4, 6 minus 2 is 4, 1 minus nothing is 1. 144 over 169. Maybe I'll even go ahead and point out 144 is 12 squared. Check that if you like. Divided by 13 squared. So I see that s is equal to plus or minus the square root of 12 squared over 13 squared is plus or minus 12 over 13. Now, I know that 3 pi over 2 is less than b is less than 2 pi. What quadrant is that? That is quadrant 4, sine b is negative. So that means I know that it must be negative. So what have I computed? I've computed the sine of b is negative 12 over 13. Oh, groovy. Now I know what all of the ingredients are. So the cosine of a at the top of the page is 3/5 times the cosine of b, again, top of the page, is 5/13 minus the sine of a is 4/5. Right, that it comes from there. Times the sine of b is negative 12 over 13. Now it's just a matter of doing the arithmetic. So first things first, I guess those two negative signs cancel. And let's write down the denominator. So the denominator of each of these fractions is 5 times 13 is 65. If that's too quick for you, then go ahead and pause and check that 5 times 13 is 65. 3 times 5 is 15, plus 4 times 12 is 48. Adding those numbers together, 5 plus 8 is 13, carry the 1, 63 over 65. Next, let's check sine of a plus b. So, zooming out so I can remember what all of the ingredients are. They are now on the page. Sine of a is 4/5 times the cosine of b, which is 5/13, plus the cosine of a is 3/5 times the sine of b is negative 12 over 13. And you might look at that and say, oh, over here I see a 5 divided by 5, so I should cancel those, but I need to combine these fractions anyway, and there's no cancellation in this term. So let's combine the fractions into a single fraction, then see if there's any fortuitous cancellation. I don't think there will be. So again, the denominator, I see these both have the same denominator. They both have a 65 in the denominator. 4 times 5 is 20, minus, this time, 3 times 12 is 36, and it's negative, hence this negative sign is equal to negative 16 over 65. And let's make a quick check of this. So let's check first whether these answers are at least consistent. All right, sine squared plus cosine squared should be 1. So in order to do one check, and I know this is off of what your physical paper is capable of traveling to the left, but that's okay. 63 over 65 squared plus negative 16 over 65 squared. That negative sign doesn't matter, it's being squared away anyway. Let's use a machine to compute that. Hopefully we get 1. Okay, do that. Take a machine, plug those things in, see what you get. Good. We got 1. Which is what we needed to get. Maybe we can also meditate on whether these two quadrants are reasonable. Next, let's check if cosine being positive and sine being negative is reasonable given the information we have. So let's see, I know that 0 is less than or equal to a is less than or equal to pi over 2. I know that 3 pi over 2 less than b less than 2 pi. Hope those were strictly less thans. I can add inequalities together. I'll see that 3 pi over 2 is less than a plus b is less than 2 pi is 4 pi over 2 plus pi over 2 is 5 pi over 2. That traces out, these two quadrants. So in those two quadrants, cosine is positive, sine might be positive, might be negative. These conditions satisfy that. Cosine is positive, and I couldn't tell whether sine should be positive or negative anyhow. Radical. So with those checks out of the way, let's move on to something slightly more abstract, not much more abstract. Let's try to get a double angle formula. So let's try to compute the cosine of 2 theta, and in fact I'm going to return 3 different formulas. So let's do this. So I want the cosine of 2 theta, that is the same thing as the cosine of theta plus theta. I can use the angle addition formula now. So this, I'll take that to be the a in the angle addition formula. I'll take that to be the b in the angle addition formula. So I should wind up with the cosine of a, which is theta, times the cosine of b, which is also theta, minus the sine of a, which is theta, times the sine of b, also theta. I get cosine squared theta minus sine squared theta. And now I'll point out here that it says to find this column 3 different formulas. So there's one of them. There's one formula for angle addition. Maybe I'll number that with a 1. Erase that accidental highlighting. There's formula 1. Let's get some more formulas. So one thing which maybe you'll find upsetting is that means that the formula for the cosine of 2 theta involves both cosine and sine. Maybe that's not so surprising because the angle addition formula uses both cosine and sine. But notice it doesn't have to. Could I express that sine squared in terms of cosine? Of course I can. By the Pythagorean identity, that's the same thing as the cosine squared of theta minus 1 minus the cosine squared of theta. Simplify that a little bit. When I take that negative sign and distribute, you will see 2 times the cosine squared of theta minus 1. There is the second formula. You could do the same thing, and maybe I won't write up the steps, to see that you will get also 1 minus 2 times the sine squared of theta. So the 3 different double angle formulas for cosine say that cosine of 2 theta is the same thing as cosine squared theta minus sine squared theta. Is also the same as 1 minus 2 cosine squared theta is also equal to 2 times the sine squared of theta minus 1. All of those things are equal to each other and are all equal to the cosine of 2 theta. Similarly, we can get a formula for the sine of 2 theta. You should do that, but I'll do it too. So the sine of 2 theta, well, that will be the same thing as the sine of theta plus theta. Put those parentheses in, why not? Well, look at that. That will be, there's the thing that I'll take for A, there's the thing that I'll take for B. So I'll see the sine of A times the cosine of B plus the cosine of A times the sine of B. Oh, hey, look, that's just sine times cosine plus multiplication. It doesn't matter what order you do it in. Sine times cosine. I see sine cosine plus sine cosine. A thing added to itself is just 2 times that thing. This is 2 times sine theta cosine theta. So there's the double angle formula for sine. And I'll encourage you to have those internalized or on a note sheet for the sake of whatever exam rolls around. Big picture, after this class is done, it's much more important to be aware that these formulas exist than knowing exactly what they are. If you're in a situation where you encounter a double angle, you can be aware that, I know there is a double angle formula, let me go look it up, and then I'll be able to use it. So I'll stop that video here. The final thing that I'll want to talk about in this series of videos is, what about tangent? I've totally neglected tangent. Let's fix that. See you in a few.